That sounds great. All right, everyone, welcome. Thank you all for being in attendance today. I just want to start with a brief introduction about the meeting and our goals and intention for the meeting today. What we, the San Mateo County Parks Department, are hoping to provide through this webinar and meeting is an overview of the work that we are doing to initiate a pilot program for cattle grazing at San Mateo Mountain that will help to determine the efficacy of this type of cattle grazing activity as a tool for the benefit of the protected butterfly species and their habitat at San Mateo Mountain. We will be providing a number of presentations today from ourselves at County Parks, as well as presentations from the members of the Grazing Technical Advisory Committee, who are the other panelists for this meeting today. And the intent with these presentations is to provide some information on the background and the scope of the grazing pilot program, and on the knowledge and the considerations that we're taking into account for the development of the pilot program. We'll introduce you to the members of the Technical Advisory Committee that are assisting County Parks by providing their expertise and the knowledge that they have in the areas of butterfly species research and management, rangeland ecology, and protected species recovery and regulations. So the audience today is made up of a variety of people associated with conservation and resource management organizations, with advocacy groups, with biological and rangeland professionals, public lands management agencies, and government staff. We have invited you to attend this meeting to participate in the discussion and provide input and feedback to us on the program, and for input on your areas of expertise as it pertains to conservation grazing. For the portion of the meeting agenda, we will also be providing opportunities for questions and comments, at which time we'll invite you to raise your hand or pose any questions to the panelists. If there's anything we do not have time to fully address or discuss, or if there's not time for a specific question you have, we will be sure to make note and follow up on all the questions and comments after the meeting, and to make sure all this information is shared. So for the meeting today, we have Janeth is on the meeting to act as a moderator and to address any sort of technical or meeting related logistics. And so when we do get to the question and comment periods, she'll be able to provide mic access or address any comments that come up into the chat and direct those to the panelists. From San Mateo County Parks Department, myself, Hannah Ormshaw, I'm the Natural Resource Manager for the County Parks Department. And as part of that role, I am acting as the Habitat Manager for the San Mateo Mountain Habitat Conservation Plan. We also have Evan Cole. He is a Natural Resource Specialist for the County Parks Department, and he is also very closely involved in all the activities at San Mateo Mountain as well. For the Grazing Technical Advisory Committee and the panelists that you'll meet and are presenting today, we have Larry Ford, a certified rangeland manager, works for LD Ford Rangeland Conservation Science, along with Felix Ratcliffe, who's also a certified rangeland manager. We have Joseph Terry, a senior biologist for the U.S. Fish and Wildlife Service, who provides oversight and administration for the Habitat Conservation Plan for San Mateo Mountain. We have Stu Weiss, the chief scientist for Creekside Science, with expertise in protected butterfly species within the Bay Area, and Sheila Berry, a livestock and natural resources advisor from the UC Cooperative Extension. We also have, as a member of the Technical Advisory Committee, Dr. Ryan Hill with the University of the Pacific. He is not providing a presentation today, but he is another member of the Technical Advisory Committee, providing advice and expertise for the program. So for the agenda today, you can see currently right now we're just going through some introductions. Next we'll have an overview presentation by myself and Evan that will go a bit into the background of what we do out at San Bruno Mountain and what work we've been doing to date on the grazing pilot program. And then, as you can see, there's a series of other presentations focused around the protected butterfly species, populations and their biology, around native grasslands, nitrogen deposition, management for species conservation, and around rangeland related biomass, forage production, and grazing strategies. And then with in between sets of presentations, we'll be taking some breaks for questions and discussion so that it's not all left until the end. But then we do have a period of time at the end as well for any additional questions that might still be out there. All right. So with that, we can get right into the presentation. So just to provide a little bit of background, the San Bruno Mountain Habitat Conservation Plan, or referred to as the HCP, or San Bruno Mountain HCP for short. This was something that was originally created in 1982 as a response to the listing of mission blue butterfly as an endangered species, as well as some grassroots advocacy for the long-term protection of San Bruno Mountain as open space and protected habitat, and the efforts to prevent this area to be developed as urban and residential land. The San Bruno Mountain Habitat Conservation Plan was the first of its kind in the country. It was developed by the U.S. Fish and Wildlife Service as a plan to conserve habitat for the endangered butterfly species that call this mountain home. And as part of the San Bruno Mountain HCP, there was some compromise in order to allow some limited development to continue to occur within the plan area. So the purpose of the plan is to identify and provide guidance on the management and monitoring actions that are needed to assess the status of the butterfly species and other protected species that live at San Bruno Mountain. And also advice and guidance, or guidelines and guidance on how to conduct different management activities for the benefit of the habitat. Since the 1982 plan, there have also been supplemental assessments and reports that have been completed to assess the efficacy of our habitat management activities and to make recommendations on how to improve on how we conduct our management and monitoring work. And continuing to ensure that these activities are occurring with the best available scientific knowledge and effectiveness for the time. While there are a multitude of landowners within the HCP area, the majority of the land area is owned by San Mateo County Parks and is managed as conserved habitat as well as a public park. Because of this, the San Mateo County Parks Department has the primary responsibility of implementing the Habitat Conservation Plan, conducting the monitoring, the habitat management activities, and monitoring compliance with the federal species regulations and recovery actions. Next slide, Evan. So our focal butterfly species that are present at San Bruno Mountain and that the Habitat Conservation Plan and our subsequent management guidance documents focus on our Kilby silver spot, San Bruno elfin, and mission blue butterfly, which are 3 federally endangered species. We have a 4th species, a federally threatened species, bay checker spot butterfly, which at the time the San Bruno Mountain HCP was developed, was determined no longer present. However, it was still considered critical habitat for the species. And one of our panelists will go into a bit more detail later about more recent efforts to reintroduce that species. Next slide. For our host plant species, we also conduct monitoring and mapping for the core butterfly host plants, since these are really quite used as a proxy for the butterfly habitat and for habitat quality in general. Because the butterflies, all of the butterfly species are very closely tied to the host plants for various life stages of the species. We assume if a host plant is present, that the species may also be present, and we use monitoring of the butterflies and the butterfly host plants to corroborate and correlate this understanding. It's also beneficial for us because they're identifiable for a longer portion of the year. So monitoring of host plants is a bit more or a bit less restricted than monitoring for the butterfly species itself. So it is an ideal component to our species monitoring activities as well. Next slide. So San Mateo County Parks Department, as I mentioned, plays a large role in the activities that occur at San Bruno Mountain. It's the department's natural resources staff that act as the habitat managers for the Habitat Conservation Plan, conducting the annual monitoring of the species, determining priorities for habitat management, prescribing and hiring contractors to conduct the habitat management work, and implementing and submitting annual reports for monitoring and management to the U.S. Fish and Wildlife Service. We also review all proposed activities that occur within the Habitat Conservation Plan area, such as scientific research, maintenance of utilities, and plans for development, to ensure that impact avoidance and minimization for these activities is always followed. Next. So some other roles that are important for the implementation of the San Bruno Mountain HCP. We also meet quarterly with a natural resources coordination group whose members are listed here, and many of whom are also in attendance for this meeting. The purpose of these meetings are to discuss and review our natural resource management work, our habitat management activities, monitoring, and to seek input from the group on how we prioritize and conduct these activities, and discussing other research and stewardship work that's conducted by county parks and by the group as a whole. The county's role is defined as the plan operator and the habitat manager, and we also report and coordinate with the U.S. Fish and Wildlife Service. And then we have the HCP trustees who oversee the trust fund, the budget, and the expenditures for the HCP. Next. So here are a few images of our monitoring activities in action. So these photos were all taken this spring during our San Bruno elephant surveys. So these are pictures of the natural resources management staff. And we're all biologically, have biological and ecological backgrounds and have training in the monitoring protocol and identification of the species. If you're interested in knowing the results of our monitoring work and our observations every year for each of the butterflies that we do monitoring for, we will have an annual report for 2019 and 2020 submitted to Fish and Wildlife Service this December and would be made available to and posted at the County Parks website probably by January if you're interested. We also have all of our past annual reports posted there if you have interest in seeing the monitoring results from other past monitoring years as well. On top of the results of our butterfly monitoring work, these annual reports also cover descriptions of our annual habitat management work as well. Next slide. So speaking of our annual habitat management work, there are a variety of methods that we currently use or that are identified within the Habitat Conservation Plan as tools within our toolbox for doing our habitat improvement work. We also have the 2008 Habitat Management Plan, which expands on or identifies additional approved tools for habitat management at San Bruno Mountain. The primary drivers of habitat degradation within the habitat are scrub encroachment, overgrowth of non-native annual grasses, and spread of invasive weeds. So the techniques we primarily use currently and the intent of our management actions focus on removal of scrub and invasive species, reduction or reversal of habitat degradation, and containing or reducing weeds or scrub encroachment. So it's important to note, however, aside from a small scale goat grazing trial and a prescribed burning trial, burning and grazing are not presently used across the mountain. Mechanical, manual, chemical control and volunteer stewardship are really our primary tools that we're utilizing right now. But of course, you know, the purpose of this meeting, we are looking into utilizing grazing to a greater extent. Next. So to provide a bit of an illustration to the group for how much work we accomplish annually with the budget that we have for habitat management work, we're relying heavily on contractors to conduct the vegetation management activities. And you can see here for 2019 and 2020 calendar years, the amount of acreage of habitat management activities accomplished with a comparison for the cost for 2020. So the acreage treated for 2020 is about 122 acres of a combination of chemical, mechanical, and manual treatments, which comes up to that total cost. So really this is just to illustrate that it is quite costly to hire contractors for this work. And it averages out to about $1,500 an acre for treatment using these methods. Next. So this is a list of the typical invasive species targets that we typically focus on and prioritize for treatment. On the list, you can see also at the end there miscellaneous scrub species, and this includes native scrubs in most cases, such as coyote brush, sagebrush, coffeeberry toyon, which are common coastal native scrub species that are expanding into the grassland at San Bruno Mountain, and that we work to reduce to prevent conversion of grassland into scrubland over time. What you might notice is absent from this list is non-native annual grasses. We found that large-scale efforts to address the grasses are prohibitively expensive or infeasible due to the terrain, such as having a contractor bring mowing equipment to mow and reduce the grass cover. So far, that's just not been a feasible method for us to address grass. Next. While I mentioned grazing is not currently present at San Bruno Mountain, it is important to note that there is a history of grazing that has occurred at San Bruno Mountain. The mountain was a working cattle ranch in the period between the late 1700s and the early 1960s. In the 1960s, cattle were removed from the mountain. And after that point in time, we started to observe a significant loss in grassland habitat over time with the expansion of woody coastal scrub vegetation. Of the mountain's approximately 3,000 acres, you can see that there's been some changes and decreases in grassland extent measured over time. By the time the 2015 assessment of the habitat conservation plan had occurred, it was estimated that the grassland coverage equated to just 1,180 acres, and that equates to about a loss of 9 acres a year over time. So it's really our goal to prevent the ongoing loss of grassland habitat and to maintain a minimum of 12,000 acres of grassland across the mountain. And as you can imagine, conducting the habitat management work on roughly just 125 acres a year is a daunting task. So we're looking for other methods to help us achieve this. Next slide.
Okay, I will take it from there, Hannah, thanks. I'm Evan Cole. I'm a natural resource specialist with San Mateo County Parks. You guys have all been receiving plenty of emails from me in the past few months, so thanks for everyone for attending. I'm just gonna give a quick overview of the grazing program itself. I'm not gonna go into too much detail because much of this will be covered in a lot more depth by our later panelists. But I wanna give you just a general understanding of what our goals are and how the program will be implemented. So just generally speaking, the main goals of the grazing pilot program, the primary one is butterfly habitat, increasing the host plants and the wildflower habitat for these endangered butterfly species, as well as the federally threatened bay checker spot. So that's the primary one. Fuels reduction is a secondary goal. Both of these areas are surrounded by residential and commercial developments. So there's a lot of incentive to reduce the fuels, especially with the prevalence of wildfire risk on the mountain itself. Invasive plant management also, just generally trying to follow through with the goals elsewhere on the mountain of reducing invasive plant cover and just continuing on with the other kinds of control methods that we've been using. Reducing scrub encroachment is also a goal that kind of just fits in with those other goals too. And you can see here a photo. It's a really cool depiction of how grazing can actually impact habitat. On the left of the fence there you see ungrazed pasture, and on the right you see a grazed pasture with a lot more wildflower, a lot less grass height and cover. And on the right you can see there's a mission blue butterfly egg on a lupin. Grassland habitat and endangered species objectives. So more specifically, through our monitoring over the course of this grazing program, we're going to be using a variety of metrics and success criteria to evaluate how well we're achieving those goals that I just outlined. Some of those include reducing just non-native annual grass cover, reducing the thatch buildup that is occurring underneath all of this invasive annual grass cover, increasing native forb cover and diversity, specifically being the host and nectar plants that these butterflies utilize, and slowing and hopefully reversing the scrub encroachment that's been occurring. So we'll be measuring those through our monitoring program, and we'll be including those in our reports and hopefully have some good news for everybody. This is another good example of what we're kind of imagining and what we're going to be looking for through our monitoring and in our objectives. On the left, this is a grazed slope. You could see viola popping up all over the place. On the right, it's the same slope, just from a different year when it hadn't been grazed for a while, and it looks a lot more like San BRUNO Mountain right now, with a lot of invasive annual grass cover and a lot of height, and it's just crowding out all the wildflowers. So this is the general kind of plan we have. We're going to be developing a grazing strategy with our rangeland management consultants. Two of them are on the meeting today, so you'll be hearing from them. But we'll be using a science-based study design to develop our kind of plan of action for how many cattle to put down on the mountain, where specifically to target, rotation plans, and seasonality. And this will help inform the lease agreement we eventually get into with a grazing vendor. And we'll talk about that more later too. The monitoring plan we will develop more in-house through our natural resources department, but that will just include a lot of targeted monitoring efforts in addition to our usual annual butterfly counts and host plant monitoring in order to see how well we're achieving our success criteria. And we'll be trying to implement adaptive management throughout the course of the years that we'll be doing this pilot grazing program. Because if something's not working, we definitely want to readjust and recalibrate how we're implementing the program. And through all that, we'll be reporting comprehensively the results of the program, and we'll be doing hopefully more public outreach just like this to get input from not just the general public and local stakeholders around the mountain, but also conservation groups like those on the call today. So just to give you a geographical sense of where we're talking about specifically, the green area on the north end, the green polygon, that's what we call the northeast ridge. So that'll be one area we plan on putting cattle down. The southeast area in yellow is the southeast slope, it's called, and that will be the second pilot grazing area. Those will be the only two areas at this time that we plan on implementing this grazing program. And this will give you kind of an idea of what it looks like on the ground. Northeast ridge on the left, southeast slope on the right. You can see the southeast slope is actually a little bit bigger. These totals are total acreage, so obviously not every bit of acreage on this mountain is what we would consider grassland or grazable area, especially these places that have already been taken over by shrubs. But this gives you an idea of the scope that we're talking about. And progress to date, we've developed a grazing technical advisory committee who we meet with quarterly to get input on the planning process and develop action items to come so that we can keep this program moving forward. And we've been meeting with them for years now. So we're going to continue with that. Literature review and agency consultation in-house. The Natural Resources Department at San Mateo County Parks has already been spending months having conversations with other land managers to get ideas of common pitfalls with conservation grazing, what works, what doesn't work, and how we can make sure that we start off on a good foot and avoid making any easy mistakes. And also to help facilitate with our own operations staff how this program will actually be implemented logistically. So we've talked with Grassland managers at Mid-Peninsula Open Space District, Santa Clara County Parks, East Bay Regional Parks, Point Reyes National Seashore. So we've really tried to cover the whole gamut across the Bay Area. We've also just finished through our consultants, our biological consultants, baseline biological assessment of these grazing areas, including comprehensive plant surveys and wildlife surveys. And our rangeland consultants have also just completed a biomass and productivity study, which I was lucky enough to be able to help with in the field with the sampling, and they will talk more about that later. Next steps on our agenda are going to be developing a grazing strategy through our rangeland consultants and developing our own monitoring plan based on what we want to see happen and result from this pilot program. Developing the actual infrastructure, so there's not currently any fencing or water infrastructure for the cattle in place at the moment. So that's a large hurdle that we still need to accomplish over the next year or so. And there also may need to be some access improvements to help facilitate getting the cattle on the mountain safely and easily. We need to solicit a vendor, so a grazer who will actually come out and you will be able to use their cattle. So we need to develop a license agreement that favors all the conservation goals that we have in mind. And we'll be developing that in the coming months. And then finally, through our monitoring program, we'll be doing repeat biological surveys, productivity, biomass sampling immediately prior to the introduction of cattle and throughout the grazing program so that we can monitor the efficacy of the program. If you have not checked out our website yet, please do. There's a form you can fill out if you want to be kept up to date on our latest events or upcoming public outreach meetings like this one, or just to be looped in on some of the results we've had lately. So that's the end of Hannah and my presentation giving an overview. We'll move right into the next panelist, who is Joseph Terry with U.S. Fish and Wildlife.
Hello, everybody. I'm Joseph Terry, a senior biologist with the U.S. Fish and Wildlife Service. And today I will be talking about the San Bruno Mountain HCP, grazing, and protected butterflies. Next slide, please. So the Fish and Wildlife Service leads for San Bruno Mountain are myself, Joseph Terry, a senior fish and wildlife biologist with the Sacramento Fish and Wildlife Office. I've been involved in the San Bruno Mountain HCP for 10 years, the Santa Clara Valley HCP for 7 years. I do Endangered Species Act consultations, both HCPs and Section 7, and I'm locally based here in San Francisco. Also on our team is Samantha Lance, a fish and wildlife biologist with our recovery division. And she is the recovery lead for listed butterflies. And she does recovery plans, species status assessments, 5-year reviews, and recovery permits for the listed butterflies. Next slide. Here's an overview of what we do at the Fish and Wildlife Service. Our mission is to work with others to conserve, protect, and enhance fish, wildlife, and plants and their habitats for the continuing benefit of the American people. We use the best available science in our decision-making and foster relationships that result in tangible conservation actions. And here you can see the various things roles that we have, and the ones highlighted are the ones that are relevant to today's presentation. So we protect listed and at-risk species through listing decisions, 5-year reviews, species status assessments, and recovery planning and implementation. We also work with other federal agencies under Section 7 of the Endangered Species Act, but that's not applicable to today's conversation. And we work with private landowners and other non-federal agencies under Section 10 of the Endangered Species Act in doing habitat conservation plans. Next slide. So here's the San Bruno Mountain HCP at a glance. So we have been working with San Mateo County Parks to implement the HCP for almost 40 years. In 1983, it became the first HCP in the country. It protects 3 endangered butterflies and 1 threatened butterfly. It has a goal of between 1,200 and 18 acres of grassland habitat protected and managed for the listed butterflies. However, a recent assessment showed that on average, 9.5 acres of grassland habitat have been lost each year since 1983 due to invasive plants and the encroachment of native shrubs, and actually recently dipped below that minimum threshold of 1,200 acres of grassland on the mountain. We recognize the need for funding for managing invasive plants and shrub encroachment. We analyze ways to reduce invasive plants, including controlled burns, hand removal, and grazing was determined to be an appropriate activity to be included in the HCP. Next slide. So here again are 4 listed butterflies on San Bruno Mountain. The Mission Blue butterfly, endangered. In September 2019, we issued the Recovery Plan Amendment, which lists habitat loss due to shrub encroachment as a serious threat. And the criteria to downlist the butterfly to threatened is that San Bruno Mountain must have more than 1,200 acres of grassland habitat. the Calliope silver spot butterfly, endangered. In July 2020, the species status assessment recognized the need for grazing to manage invasive grass and thatch, and the 5-year review recommended a pilot grazing study to reduce non-native grasses. Also currently, the Ridgetop Conservation Bank in Solano County uses cattle grazing to manage habitat for the butterfly. The San Bruno elfin butterfly, endangered, so there would be no grazing of San Bruno elfin habitat, which occurs on rocky north-facing slopes where invasive grasses are not a concern. Instead, there would be the hand removal of shrubs encroaching on its host plant, Pacific stonecrop. And finally, the bay checker spot butterfly, threatened. It was recently reintroduced to the mountain a few years ago. Cattle grazing is essential to maintaining its habitat in Santa Clara County, and the removal of cattle grazing has resulted in the local extirpation of the bay checker spot butterfly from some locations. Next slide. And we have one endangered plant on San Bruno Mountain, the San Francisco lozenge. It occurs on dunes on the western slope, which will not be grazed. And currently we are funding $20,000 for San Bruno Mountain Watch's restoration proposal for the lozenge. And next slide, that's the end of my portion of the presentation. Thank you.
Okay, thanks, Joseph. I think next we have Stu up. Stu, you want to share your screen?
Yeah. Okay, I am going to do a whirlwind tour of the butterflies of San Bruno Mountain. And if I can get my screen to... So the grasslands of San Bruno Mountain are a really remarkable ecosystem that supports 3 quite rare butterflies that are listed under the Endangered Species Act, a real hotbed of biodiversity. So the Mission Blue butterfly is maybe the most famous. It requires lupins as its larval host plant. And over the decades, here's all the places that Mission Blue butterflies have been seen in from 1982 to 2001. So we can see all across the mountain, pretty much anywhere there were more than a few dozen lupins would be occupied by Mission Blue butterflies at one time or another. But over time, there have been some serious losses of Mission Blue habitat. These are areas where native scrub encroachment really led to the loss of local Mission Blue habitat and populations. And then under the HCP, there's some limited areas of development that took out former Mission Blue butterfly habitat. In Owl and Buckeye Canyons, one of the richer habitats on San Bruno Mountain, all the dots are Mission Blues from various years. And you can see how much scrub there is currently. This used to be mostly grassland. So we've lost substantial areas of Mission Blue habitat to coastal scrub encroachment. The Mission Blue trends from the monitoring, there's a lot of data here. I'm not going to go into it too much. First is that fluctuations are a normal part of butterfly populations. These sites on the main ridge of San Bruno Mountain have shown, mixed results and a recent uptick in Mission Blue habitat and Mission Blue numbers. Here on the northeast ridge, which is one of the areas proposed for grazing, we've seen a decline of the mission blue butterfly through time, largely because the lupins have been disappearing and not recruiting. So it all comes down to the lupins. There are 3 species of lupins that the mission blue uses. There's a silver lupin on the left with San Francisco way, way in the background. And then this is a berry lupin on the right. Lupins love to grow on disturbed soils, rock outcrops, road cuts, and are a really important part of the grassland flora for reasons above and beyond supporting the mission blue butterfly. Here's how the mission blue uses lupins. There's an egg nestled into the crease of the lupin leaf. And then on the right, we have a mission blue larva, which feeds on the foliage and has that cool little racing stripe on it. So in terms of habitat management, we're learning now how to propagate lupins by seeds in places like this road cut, where it's really difficult to plant plugs. And we've had quite a bit of success with that. This is a project funded by the Disney Butterfly Conservation Initiative. All of the circled plants are lupins that are emerging from the seeds we had planted earlier that year. And the key is to plant the seeds very, very carefully, one by one, to give them a good place to grow. So we're learning how to propagate lupins, especially in areas like road cuts. San Bruno Mountain is also served as the source population for translocations to Twin Peaks and Milagro Ridge. This is Sean Correa, who used to be with the Golden Gate National Recreation Area, now with San Mateo County Parks, contemplating taking this mission blue pair to Milagro Ridge. So San Bruno Mountain serves a really important source population for other efforts with the conserving the butterfly. So just in summary of the status and trends, it's the lupin populations are the key. There are 3 species. The diversity of lupins guards against what we call fungal meltdown of Lupinus albifrons, the silver bush lupin. During El Nino years and warm, wet springs, the albifrons gets hit by a fungal disease and can lead to severe collapses of mission blue populations. The loss of lupins to coastal scrub and lack of disturbance in the grasslands have led to the decline of lupin populations. They need to be refreshed on a decadal time scale. The individual plants are not particularly long-lived. And now with seeding, we have the means to establish lupins on rocky cut slopes where they can thrive by themselves. And the point is to let the lupins be the lupins. They're very good at colonizing bare areas. They're really bad at colonizing thick grass and thatch. Now we're going to quick look at the San Bruno elfin. Feeds on the succulent sedum. The upper left is some sedum flowers. There's a elfin larvae feeding on the sedum rosette, nice succulent rosette. And if you look closely, you'll see these white eggs. That's a parasitoid, probably a tachinid fly that is going to hatch and eat out the inside of the elfin pupa and emerge as a fly. It's a major source of mortality for San Bruno elfin. When you get a good view of the butterfly, it's gorgeous and intricate on the underside of the wings, but when you see it out in the wild, you typically see a pretty dull-looking brown butterfly. There are discrete populations across the mountain on these rocky north-facing slopes, very well mapped out. Most, if not all, of the known habitat is still occupied. There's no development threats through time. Scrub encroachment may be a local issue, but the rocky habitat is quite resistant. and it's not going to be affected at all by any grazing on grasslands. Now we're going to talk about the Calliope silver spot butterfly, big, beautiful, powerful flyer living in open grasslands where we find stands of Johnny jump ups or Viola pedunculata. Gets nectar from a really wide variety of species. Interestingly, these are two non-native species that the Calliope gets nectar from. Here's the distribution of Calliope kind of cumulatively from 1982 to 2001. Pretty much all over the mountain in open grasslands that have violets in it. Over the course of time, these areas have been greatly reduced or eliminated, the Calliope in these areas, because of the scrub encroachment. And then parts of the habitat, same as the Mission Blue, have been lost to development. But there still are large swaths of grasslands that are maintaining Calliope silver spot populations. This is a typical scene in the really high quality Calliope habitat where the yellow violets are a really major component of the grasslands. These tend to be the upper slopes of the mountain on north-facing slopes that really retained a lot of the native biodiversity. Elsewhere on the mountain, on the northeast ridge, we find that the grasses have really, really dominated, and the distribution and abundance of the viola has been greatly reduced over time. Here's an example of some viola growing up through really thick grass and thatch layer. It's basically going to be buried in grass by the time the grass grows and senesces. So the grass and thatch are a really major threat to the viola, hence a threat to the Calliope silver spot. The trends from 2000 to 2018, real boom and bust, typical of butterfly populations. And there have been recent declines in 2016 and 2018. I have to see what the 2020 data show. And so in summary, it requires open grassland with Viola pedunculata, Johnny jump ups. It's a very powerful flyer. It's really threatened by scrub encroachment, and even more so by annual grass growth and thatch buildup as a major threat to the violets. I'll be talking a little later about how atmospheric nitrogen deposition increases grass growth. And this is definitely a case calling for considering grazing to reduce the grass and thatch cover. Then we have the bay checker spot butterfly. This is the threatened one. Here's the different parts of the life cycle. We have a mating pair of adults in the middle. There are eggs on the right. Below we have freshly hatched larvae. On the left, we have a post-diapause larvae hanging by a thread on a Plantago lanceolata with San Francisco in the background. This is what the native habitat for bay checker spots on San Bruno Mountain looks like. There are very few areas left like this because of the encroachment of grass, non-native grasses and forbs. There's host plant Plantago erecta, the little silvery plant, and then owls, clovers, and other host plant, but a variety of native forbs and very little annual grass. The butterfly was last observed naturally during the period 1982 to 1984 along the main ridge of the mountain, and then it just disappeared because the habitat got invaded by grasses and non-native forbs, especially erodium, got too fragmented to support and too small to support bay checker spots. So this is it being the 21st century, we have to open our minds a little bit to trying something else. So the non-native Plantago lanceolata on San Bruno Mountain is very, very common. And checker spot butterfly populations up in Oregon and Washington and in the Eastern Sierra have switched their host preference to non-native Plantago lanceolata. So with support from the U.S. Fish and Wildlife Service and the Central Valley Project Conservation Program, we've been translocating bay checker spot larvae on the San Bruno Mountain. There's Curus Swinnerton spreading the larvae, as we said, and there's a caterpillar just starting to feed on the Plantago lanceolata, and that happens to be a viola right next to it. We've moved up thousands of larvae over a 4-year period. The details of this can be found in our semi-annual reports. And we're taking them out of a huge source population on Coyote Ridge in South San Jose. And in 2020, we got off the main ridge and we've released them in Owl and Buckeye Canyon. We monitor the adults by walking transects, count them up in 50-meter segments. It goes from end to end on the main ridge here. The butterflies down at this end, the butterflies down at this end, and quite a few in between. This is 2019. We've been on a bit of an increase. The first year is the blue. We added a bunch more. We got more, and then we added a whole bunch more, and we got even more, and the populations have been successfully reproducing, and well, have a new 2020 graph this year. So far it's been pretty successful. Plantago lanceolata does quite well in grazed habitats. So to reemphasize, the biggest threat to the grasslands on San Bruno Mountain is the native scrub encroachment. So here's the, call it transmission line ridge. This is Buckeye Canyon here. This is what it looked like in 1982. And this is what it looked like in 2006. We've lost more than half of the grasslands in that area, much to the detriment of both the Calliope silver spot and the mission blue butterfly. As part of the 30-year review of the HCP, native scrub management became a really, really important emphasis. We've zoned the grasslands into the essential areas and the valuable areas where scrub management becomes a big priority, basically defending what we have, because the first rule of grassland management is to keep it a grassland. Once it turns to scrub, it's very, very difficult and time-consuming to turn it back into grassland. So that's my whirlwind tour of the butterflies of San Bruno Mountain. We think we want to test whether grazing can benefit the Calliope silver spot, mission blue, and bay checker spot butterflies up on the mountain. So thank you.
Thanks, Stu. If you want to unshare your screen, we're about 10 minutes behind schedule, so we kind of ate into all of our question time, but we can probably do a few minutes of it. I'll let Janet give a quick little introduction to how we'd like the questions and discussion to work. But before that, I'll just note that we've now kind of heard talks on the overview of the program, San Bruno Mountain, and butterfly biology. We haven't gotten yet into the real meat of the discussion as far as the role of conservation grazing as a tool for ecological restoration, or the studies that we've currently been doing in our own program. So just know that some questions may actually be answered later, so we may just end up having to put them off.
Thank you, Evan. Just a quick reminder that this meeting is being recorded and will be available to the public shortly after. During the general public comment period, and for those talking about each agenda item, please use your raise your hand feature to raise your hand to speak on that agenda item. For those joining by phone, please press *9 to indicate your desire to speak. When you hear your name called, I will prompt you to unmute your account and inform you that you may begin speaking. Please note that you will have 2 minutes and will be notified when the time ends. Thank you. So right now I see 2 hands raised. First I see Del Shimbari, followed by David. So one quick second while I put the timer up. So Del, please accept this invitation and unmute your mic and you can begin speaking.
Unmute. Okay, can you hear me?
Yes.
Okay, I just want to, Stu said it was like, those were the butterflies, but those were mainly the, those were all the endangered butterflies on the mountain. And I just want to put in a hooray for the pipevine butterfly over on the west side of the mountain. And I also want to manage, of course, I'm an advocate for fire on the mountain. I'm trying to figure out a way how to get it done. I just want to bring that up. And that's all the time I need right now.
Thank you.
Thanks, Del.
We now have David. David, please accept this request, unmute your microphone and begin speaking. David?
You might be having trouble figuring it out.
Hand is raised.
Can you hear me now?
Yes.
Yes.
Okay, I was just going to say the chat function is not enabled, and that's a fairly useful way of communicating without interrupting the speakers. So if that's possible to enable the chat function, that'd be great. That's all I have to say.
I'll take a look in just a minute. Thank you. I don't see any more hands raised. No more hands raised. Evan.
Okay,
Thanks.
then we'll use that opportunity just to get right back into presentations, and we'll have more time later for questions. So if you do think of something, either put it into the chat if we can get that going, or just hold on to it and there'll be other opportunities to talk after the next presentation. So next we'll move on to Larry Ford with a discussion of California grasslands. And it's all you, Larry.
Okay, thank you. Whoops, let's see. That was not supposed to be my first slide. Here we go. This presentation is a general introduction to the ecology and management of the grasslands that support butterflies and other special status species in the Mediterranean climate zone. And so there's some reference in the slideshow to other sites besides San Bruno Mountain. This one in particular is Glenwood Preserve in Scotts Valley, California, which has been managed very carefully for the production of habitat of the Ohlone tiger beetle. And as a byproduct, there's been quite a bit of wildflower production on good years, but I'm going to try to describe a little bit about what that kind of careful grazing management can be. It's a combination of specifically targeting the habitat qualities that we desire, also using deferral of grazing, meaning moving the grazing off to another field when it's achieved the optimal conditions that we desire, but also very importantly, the collaboration of a very competent livestock operator, in this case cattle. So here's the outline of what I'd like to talk about in my 10 minutes. First, I'd like to discuss the challenge that people like me and Felix face as we try to apply science to maximize the benefits of grazing and to minimize the negative effects of grazing. Secondly, to discuss the conversion from a native grass or foreland to Mediterranean species that occurred sometime either before or during the initial settlement of California by the Spaniards. Third, discuss a little bit about the ecology of encroachment of native shrubs and trees into grassland, to describe the succession sear as we know it. Third, to talk about how to how to use grazing to achieve the optimal conditions of the special habitat that we're desiring. So the way I would describe the challenge is like this. California's Mediterranean grasslands are basically dominated in almost every site by 90 to 100% non-native grasses that got here somehow from the Mediterranean basin. Most of them are annuals. We don't really know what the original native grassland or forelands looked like before this kind of conversion. There's a lot of speculation, but we don't know. So Stu mentioned that California grasslands are considered to be a hotspot of biodiversity. They are recognized as a global hotspot. And so this seems paradoxical. How could an ecosystem type that's dominated by non-native species, in many cases up to 100%, that is of the herbaceous species, how could that also be a hotspot of biodiversity for all these animals? The key to it is that habitat management can be achieved effectively by using livestock grazing. So the challenge to me as an applied scientist trying to make grazing work is to integrate the biodiversity conservation objectives into the grazing management program. Livestock grazing is considered to be the most feasible management tool for this kind of work in California's Mediterranean grasslands, and cattle in particular, but other species of livestock are useful in more specific, kinds of situations. But often you can get the cattle operator to actually pay you to graze, and so that ends up being a significant reduction in the budget required for the agency that owns or manages the land. So most of the time, what we work on is trying to figure out what are the most important and feasible ways that we can improve conventional livestock grazing to accomplish biodiversity conservation. And let's jump right into how it is and when it occurred, when the conversion from a native grassland or native foreland occurred. According to theory, the transport of the seeds from the Mediterranean basin to California and basically to all other Mediterranean grasslands in the whole world occurred either when the explorers were coming along the coast in their ships or by the first settlers, which were the Spanish missions. And the specific direct evidence that we have are two that I'm going to describe in a minute. One of them are seeds that are found in some of the very first adobe bricks that were made for the Spanish missions. But another one is the design and the utilization of those ships that the explorers were using in the 1500s. The Spanish missions, you all know this from history class in grade school. The first Spanish mission in California was 1769. Anyway, so this was a significantly earlier, this other theoretical proposition is that the invasion and replacement took place much earlier than when the Spaniards got here. The second most important factor is ecological pre-adaptation. So the idea is that these seeds that came from the Mediterranean were pre-adapted. They had evolved with grazing by the animals of the Mediterranean basin, which were cattle, sheep, horses, goats, and pigs. And so one could argue that the native grazing animals for California's Mediterranean grasslands actually are the livestock that we're already using. Now, these other 3 through 8 are other elements of the theory of conversion, but I'd love to talk about that, but we don't have time to do so. The first explorers coming along the coast of California included Cabrillo. This is an actual replica of Cabrillo's ship called the San Salvador, 1542. If you look and see how big a person is on that ship, it's hard to imagine how they could have had hundreds of people on those ships. The people must have been much smaller. Anyway, here's a description of what was carried in those ships. In the 1500s, they had livestock. They had feed for the livestock. That feed got converted into manure. The manure had to be shoveled overboard. I wouldn't want to have that job. But so some of the manure probably floated in little piles, you know, to shore, and could well have landed on a beach or a rocky shore and somehow made it to the grasslands and accomplished the conversion. Also, there was almost always a horse in the hold of the ship, and that horse was used to carry the captain when the captain wanted to go ashore and explore. And so there was some direct depositing of manure containing seeds from the Mediterranean when the horses were on shore. And then we know, and has been said several times, that these Mediterranean species were very invasive, and they could have spread quickly inland from the coast. Another important part to consider was suggested by Stu. The way we have lost the grassland is not only from conversion to new set of species, but also conversion of the grasslands themselves to crop agriculture and urban development. And then there have been these cultural and economic shifts that I think are very important. The first settlers in California were focused on their subsistence. And so they did a lot of burning and clearing of shrubs in order to maintain the grasslands that they could then graze with their livestock. And so a lot of the goals that we have today that could be summed up with the one word preservation is quite different from the way it was either during the native grassland times or the time of the first settlements by the Spanish missions. And then there was natural succession in the absence of fire or something like grazing to keep the shrubs back. And this is a state and transition model that I prepared that I think pretty simply describes the way it works. Annual grassland on the left with a small amount of coastal prairie, which has a lot more dominance by native species. In the absence of grazing and or fire, some of it converts to coyote brush scrub, and with the reintroduction of fire grazing, you can have T2, the transition back to, or T3 I meant, back to annual grassland. There is some difference in coyote brush scrub or northern coastal scrub. There's a longer lived version and a shorter lived version. And then there's also a tangential version that is sometimes called blue blossom chaparral. That's dominated by a species that reproduces only after fire, and then after about 80 years or so, it senesces and dies. But most importantly, over to the right is the oak bay conifer woodland that the grassland can succeed to. And this happens, the oak and bay conversion comes in after the shrubs have invaded and established, but the conifer woodland is mostly to the north of the San Francisco Bay, and much less in the south of there. The San Bruno Mountain does have a significant amount of conifer woodland invading into the shrubs. So this is I won't go into great detail in Big Sur. This is a projection made by me showing how the grasslands were probably occurred before the cessation of burning by the Indians and settlers, and then what it looks like today. So basically inside those red lines is my projection about how the grasslands were lost over a period of about 100 years. So what do we do to try to use grazing to achieve our conservation goals? Well, the first thing to do is to try to translate what the special habitat needs are of the butterflies or the other special species into targets that can be affected by grazing. This is really important because we have to be able to tell the livestock operator what it is that we want to achieve. Secondly, to designate special management areas as distinct from areas that don't have special habitat. And then also to provide flexible use fields. These are places where you can put the cattle when they're not needed to work on the special management areas. And that's to make it sustainable for the livestock operator. Third, graze using specified targeted outcomes. So instead of saying you've got to bring in 20 cows or 15 cows with 500-pound calves for a certain period of time, which is rarely successful or even feasible. Instead, you tell the livestock operator what it is that you want to achieve and let them decide how many livestock to use. And then you have the capability of deferring grazing from the special management areas. That makes it, as I said, makes it feasible for the livestock operator to do this kind of work. And then you have to have monitoring that tells you as the agency or scientist whether or not the grazing is working. And so the best way that I've found to make this work is to very clearly define what your goals are, then to define objectives, management objectives from those goals, and then to set specific performance standards that everybody can agree on. And then lastly, it's very important, as I suggested, that the management has to be feasible and sustainable for the people and whatever tools you're using to actually achieve your objectives. Here's a couple of examples. This is from Santa Clara County Parks, Santa Teresa County Park. We designed 4 habitat fields and 4 auxiliary or flexible use fields on almost 800 acres. And it still hasn't been fully tested. There is a livestock operator working out there who says that it's working well enough, but he hasn't been able to get to all the places because of the lack of funding for infrastructure. Here's the kind of monitoring report that describes the residual dry matter or herbaceous mass, depending on what time of year you're measuring it, to tell us whether or not it's working. So basically with this kind of a map, you can see that most of the area is green, which means that it's meeting the performance standards, which are in a range from low to high. But a few areas are red, which means that it's below the minimum. And that's the danger zone. That's what we have to work on. But this kind of a map tells us exactly where the problem is. And then we can try to figure it out. Yellow is when the grassland conditions exceed the upper standard. And so that also needs some work, but it's not as important in some cases. For butterfly habitat, this would be another danger zone. If there's too much grass, if it hasn't been controlled, you've got to figure out why and what you can do about that. So to conclude, these are some summary points that I wanted to make sure that you all could think about. The grasslands were converted at some time from native to these non-native invasive Mediterranean species. Number 2, the encroachment of native shrubs and trees is due to reduced management, either fire or grazing, that has occurred since we kicked off the indigenous people and since settlers have changed their cultural ways. Number three, I call it stewardship grazing because stewardship implies conservation goals, but it also insists that this has to work for the livestock operators. If you want to have cattle, you've got to have a successful, sustainable livestock operation and industry in the area. Number four, any kind of grazing system that does not designate special management areas and flexibly used fields is destined to be unsuccessful almost every year. And so if you don't have that, then you can't easily target the special areas or defer grazing from those special areas while keeping the cattle around to be used. And then number five, focus on results that apply to management. A lot of times monitoring is focused on things that don't have a whole lot to do with management or that it's hard to interpret, but we need results that can guide us in adjusting the management through through adaptation of the plans. And then once again, number six, effective conservation. We now know, thanks to some of the luminaries in the field, including Ray Dasman, that conservation now equals sustainable development. That means we have to leave in the flexibility and sustainability for the managers to do the job that we want them to do. It's also a lot easier. And that's the end of my presentation.
Thanks, Larry. If you want to unshare your screen, we'll move on to Stu. He has his second presentation. It's on nitrogen deposition, biodiversity, and the need for disturbance in California grasslands. So,
Okay. Could I have some help? There we go. Thank you.
Stu, do you have any slides?
Let me unmute here. And ready, set, go. You see the slides?
Not yet.
Not coming through yet.
Huh. Let me share my screen again.
Okay, there we go.
Okay. See the slides?
Yep.
Okay. So I'm going to talk another whirlwind tour about a really profound change in the environment, the fact that smog or air pollution acts as fertilizer, and it's called atmospheric nitrogen deposition. One of the things about San Bruno Mountain is that it is utterly surrounded by urbanization, as you can see from these photos from the main ridge. From an aerial photo, there's urbanization and air pollution sources all around San Bruno Mountain. So I first came across this phenomenon with the bay checker spot butterfly. It lives on these gorgeous, very nutrient-poor serpentine grasslands in both the peninsula, but primarily down in South San Jose. And we found very early on in the 1980s that if the cattle were removed, we very quickly ended up with a situation on the left side of the fence here, where non-native annual grasses, primarily Italian ryegrass, just grew in, smothered the wildflowers, and then butterfly populations would go extinct. Over on the right, it's a typical grazing operation with about 1 cow-calf per 10 to 15 acres, and it's maintaining a lot of wildflowers, and the butterflies are doing fine. So we knew pretty early on that cows are really, really critical for maintaining the habitat because cows eat grass. That's what they're primarily going after, and they tend to go for the most nutritious grasses, which are the non-native annuals during the peak growing season. So they very selectively go after the non-native grasses. The reason that's happening in South San Jose lies in this advancing smog cloud. There's a process called dry nitrogen deposition, and smog is slow-release nitrogen fertilizer. And we estimate that down on Coyote Ridge, we're getting about 10 to 20 pounds of nitrogen per acre per year being deposited from Silicon Valley smog. And that's enough to change a competitive balance and allow the grasses to completely dominate. So it was written up in a scientific paper. I will post this and other papers on the website so you can read more about this. So real quick atmospheric chemistry lesson. We have combustion, i.e. like in vehicles or even your gas range, creates nitric oxide. That's a very heavily regulated pollutant because it forms ozone, helps form ozone. And that oxidizes all the way to nitric acid vapor, which is a very potent deposition agent. We also have emissions of ammonia, NH3, from fertilizer animal waste, and increasingly from vehicles because of catalytic converters and then some natural sources of it. And we get particulate formation and et cetera, et cetera. So it's pretty complicated, but the basic idea is that the air with these nitrogenous compounds act as fertilizer. So in California, some of the basics are in the dirtiest areas, like in the San Bernardino Mountains, there's up to 50 kilograms of nitrogen per hectare per year, pounds per acre, basically. Pre-industrial background is about half of a kilogram of nitrogen per hectare per year. So 2 orders of magnitude larger in the dirtiest areas. Nitrogen dioxide and ammonia gases taken up directly through the stomata of plants, a very efficient way of fertilizing. The nitric acid vapor and the ammonia stick to surfaces, even dry surfaces. Particulates and other gases are relatively minor contributors. And the dry deposition is like 80 to 90% of the total deposition in polluted regions of California, and wet deposition, i.e. in rainfall, is of lesser importance in most places. So we've investigated nitrogen deposition in the Bay Area through this network back in the early 2000s, put out these little passive sampler stations that tell us what the concentration of the gases are on a monthly basis, and then we can calculate how much nitrogen deposition occurs based on the concentration of the gases. So it extends from Edgewood Natural Preserve down to Kirby Canyon. Here's San Bruno Mountain circled in red. Our station at Redwood City is probably a pretty good analog for the urban areas just outside of San Bruno Mountain. At Edgewood, we have a nice little experiment where Highway 280 slices through a serpentine outcrop, and we have 3 stations there, one just west of the freeway, one just east, and one 400 meters east. So the basic results here are, here in the South Bay, where I showed you that fence line photo, we're getting between 10 and 20 kilograms of nitrogen per hectare per year, and that's enough to really drive the grass invasion. At Edgewood, we see right next to the freeway at Edgewood West and Edgewood East, we're getting 10 to 15. But then 400 meters east of the freeway, the gases have largely dispersed up into the air and some fraction of deposited. So it goes down really quite fast. And you can see that the biggest difference here is in the ammonia, the red bar. Is one of the dominants and dominates really close to the freeway. And then here at Jasper Ridge, which is the rural part of the peninsula, getting less than 5 and Redwood City, we're getting between 10 and 15, which represents like the urban zone. The results at Edgewood are such that here's the freeway right here at Highway 280. The axis is meters from Interstate 280. So here's east of the freeway, here's west of the freeway. We're looking at the cover of Italian ryegrass in black and Plantago erecta, the host plant for the bay checker spot butterfly, in white. And the fitted curve shows a zone where we have very high Italian ryegrass cover at 30 to 50% in a zone going out a few hundred meters from the freeway, and there's very little Plantago. And then by the time we get out about 400 meters, where Plantago goes up and Italian ryegrass goes down. So the effect goes out about hundreds of meters from a single source like a freeway. So just to make it a little more visual, there's Highway 280, 100,000 plus vehicles a day going by at pretty high speeds. The wind blows across the freeway, and that leads to about 15 pounds of nitrogen per acre per year being deposited close to the freeway. The plume extends about 400 yards from an isolated source like this, and the source is mainly, the deposition is primarily from ammonia that's being produced by catalytic converters we put on our cars, which is a whole other story. The effects can be pretty striking. We're down back in the South Bay at one of the most polluted sites. This is Tulare Hill, beautiful serpentine grassland, being grazed in 2002. When the cows were pulled off, this is what it looked like in 2007. Almost a total loss of native biodiversity under the grass and the thatch. So a true loss. We managed to get the cows back on again in 2008, and by 2014 we were back in business with bay checker spot butterfly habitat, and we actually reintroduced the bay checker spot butterfly there. So on San Bruno Mountain, we can see, knowing that this is happening, we can see the patterns. So here's the lower slopes of San Bruno Mountain at Hillside and Juncus Ravine, which is right up against the urban areas. And this area is receiving more than 10 pounds per acre per year of nitrogen. And there's a Leknalmovich with wild oats up to his waist and very, very poor quality habitat for anything other than the annual grasses. On the Northeast Ridge, again, low elevation, truly dominated by grass that smothers a lot of the native biodiversity. But we go on to the upper slopes where the deposition is much, much less because we're farther from the source and getting relatively clean marine air. We have these beautiful, diverse, native-rich grasslands. And here's a site that is really prime Calliope silver spot habitat. You see all the violets growing in there. So there are parts of the mountain that are far enough away from the deposition sources that they do maintain this beautiful coastal prairie, and the annual grasses are not nearly the problem that they are on the lower slopes. So here's a view of the Northeast Ridge from Mission Blue Drive. A lot of grass in this area. And San Bruno Mountain already has a high productivity climate. It's wet enough and mild enough that grass loves to grow there. And we add nitrogen and the grass grows ever thicker. And this is a cumulative loading process, so that over decades, we've had hundreds of pounds of nitrogen per acre being deposited into this ecosystem, and it makes the grass grow like crazy. Why grass growing like crazy with nitrogen is basically our high intensity agriculture. We feed annual grass species large amounts of nitrogen with adequate water, and we get huge productivity. This is happening on San Bruno Mountain inadvertently through air pollution. Coastal scrub encroachment is also another issue that's being addressed, and that's another reason why grazing is being considered. So the environment has fundamentally changed. We can't go back. We have invasive species, especially the annual grasses. We have the nitrogen deposition, and the combination of those two is leading to an erosion of biodiversity. And any other options besides cattle grazing have just not panned out as feasible. I mentioned a fire, we'll have that discussion later, but, and we feel it's time for an operational test on San Bruno Mountain. So here we are straddling the Cow Palace on the Northeast Ridge. This is the Grazing Technical Advisory Committee in among the dense grass. A couple of examples. Here's some viola and grazed grassland in South San Jose. Dense stands of viola. There are silver spot butterflies flying in this area in the summer. And then here's some grazed grasslands near Pacheco Pass on non-serpentine soils, where we have beautiful wildflower displays and a lot of viola. So with that, I'm going to hand the baton back to our host.
Thanks, Stu. Yeah, we're running quite a bit behind schedule, but I kind of expected that. I did provide some buffer time at the end, so we should be good. But I'll just ask the remaining speakers to try to stick to their 10 minutes so we can get address everything and get to the questions. Next, it'll be Sheila Berry. She's giving a talk on kind of the role of grazing in conservation. So go ahead, Sheila, whenever you're ready.
Okay, almost there. Okay. So yes, I'm going to be speaking about the role of livestock grazing. And I work in the San Francisco Bay Area as a livestock and natural resources advisor for the University of California Cooperative Extension. The focus of my program is to conduct applied research and extend information to more than 30 different public entities in the region that use livestock grazing to manage open space, that'd be undeveloped land for habitat, watershed, and recreation. And I particularly focus on grazing strategies for conservation of threatened and endangered species. And this is a really relevant area of focus, not just in the Bay Area, but in California, because a large percent of our state, 57%, is rangeland. And it's a really important land in regards to native diversity. And about 40% of our state is actually grazed by livestock, predominantly cattle. It is the state's rangeland that really has established California as a world's leading hotspot for biodiversity, meaning that we're really rich with species that occur nowhere else in the world. You might wonder, so why is California a biodiversity hotspot? Well, we have a unique climate, Mediterranean climate, that doesn't exist in many places in the world. Really diverse topography, soils, all lead to having diverse vegetation that then supports a diversity of fauna as well. And grazing is now really showing a role in maintaining that diversity, particularly among the vegetation.
Sheila, I'll just, interrupt you real quick. We're seeing the speaker view of the slides. If you wanted to switch it to the slideshow, it might make it easier for everyone to see.
Oh, thank you. I'm not sure where I do that because it's not showing that way on my screen.
Probably when you selected to share your screen, you might have opted for that view. You could try unsharing and resharing, or you could go into your slideshow settings and see if it's something in that.
I'm sorry about that.
No problem.
Oh, that's going to do the same. Share. Still the same, right?
No, I can see your slide now in slideshow view.
Okay. I didn't do really anything different, but okay. Well, that's good that it works that way. So yes, it's often hard to see biodiversity, but it is evident here where we have lots of native flora, like this is a site in Santa Clara County that's grazed by cattle. But it's, quite challenging, I think, to our population now in California that's becoming more, oh no, it's not moving forward. There it is. That's, often doesn't have a lot of knowledge or experience with our landscape. And it's often hard now for people to really understand what's native in our landscape and what is not. And just as an example of that, during the 2019 super bloom, black mustard was dubbed the super bloom bully when people were taking pictures and posting it thinking that they were seeing the super bloom. So it's really, I think, evident for us that we can lose habitat when we have things like development and change in land use. Way less obvious that we are losing habitat in some of our open spaces when we're not managing vegetation. As was, I think, mentioned, or I think one challenge we have in sort of protecting our habitat is not really knowing what it was. The Spaniards, when they were traveling through California in their diaries, wrote about Tierra del Fuego. And it wasn't, although translated direct to Land of Fire, that's not what they were referring to, at least the interpretations of the journal, but lots of native forbs. So we clearly know that that was a component of our native landscape, which really brings us, and it's been brought up now, I think, a couple of times with our speakers. If cows weren't here before Europeans arrived, why do they have a role in native species conservation now? And I think it's quite clear that, as has been said, the environment's really been transformed by invasive species. So we did have a collection of non-native herbivores that evolved with some of our native flora and fauna, but now we are really thinking about how we manage this non-native environment. And just to add to the sort of challenges, in addition to nitrogen deposition, we also have climate change to consider. And the scenarios around climate change and vegetation, at least in the Bay Area, are predicting that we're going to grow more forage, more grass. And that has to do with, depends on what model you look at and what sort of temperature increases you occur. But maybe we have a shorter growing season depending on rain, but with warmer temperatures, we are maybe going to see upwards to 34% more grass in some locations, including that's what you see as a scenario in San Mateo County. So thinking about the over 200 species that are listed in California, that now we might have many of them, that's 75% of the listed species that have a grazing nexus. This is really a nexus about how livestock are controlling the non-native species and maintaining habitat for both plant and animal species that are native to California. So I want to discuss what the ecological benefits of grazing are in terms of what are they managing for. And these are impacts, and absolutely grazing has an impact. And whether this impact is a positive impact or a negative impact is going to depend on the site, our goals, and how it's managed. But these impacts include potential change in species composition, ecosystem function, and ecosystem structure. And these impacts come not only from livestock grazing, that would be the defoliation of plants, but also from trampling, also from nutrient distribution or redistribution is really what's occurring in most cases, as well as from the ranching infrastructure and ranchers themselves. So in regards to species composition, the cattle grazing really makes space. Cattle prefer grass, and many of the plants that, like our native flora, are short plants that really need the biomass removed, the thatch removed, and This is an example of a grazed site in near Pacheco Pass, actually in the state park. And you can see both a native grass there as well as some of the native flora. And it's also evident in the story about the bay checker spot butterfly and the species composition that is benefited by grazing from the short plantain erecta that does better with grazing. In regards to ecosystem function, we might think about this in terms of, is it a grassland? And can we maintain it as a grassland, or is it brush? And as we won't be successful necessarily in using livestock to return brush to grass, but as has been noted by other speakers, both the trampling actually and the grazing is what's effective in keeping a grassland and keeping out keeping out the brush. And this is evident from this photo where you see the fence line and one side's grazed and the other isn't, and the coyote brush that is filled in. There are other examples of livestock maintaining function. Another one would be a stock pond, which is created by the ranchers for livestock water, but now has become valuable habitat for a couple species, tiger salamanders, red-legged frog. But you can see in this photo that the grazing is keeping, it's a creek that's actually fenced in half. And so the open water is maintained by the livestock. So maintaining the function of a pond for these species. This carries also into the ephemeral wetlands of vernal pools, where livestock grazing maintains the function by keeping them in the inundation period long enough to get a vernal pool and support the associated species that are associated with the vernal pool. And this is also a story of managing the non-native vegetation that would affect change the pool, change the hydrology without the grazing management. And the final example I want to show is ecosystem structure that can be managed by livestock grazing. So it's tall, it's short, it's bare. Those are all the things that could be accomplished by managed livestock grazing. And I want to note that it's really hard to duplicate that effort across much of a large scale with other tools, including mowing, burning, or even hand removal. That most of those other techniques are pretty all-inclusive. If you're going to mow, we're not going to get the structural, generally diversity. I suppose you could figure a way to mow in patches. It would be quite difficult. And burning generally also takes all the biomass and is often not done, maybe good for brush control and for targeting a specific plant, but also is not going to provide the annual control of our annual grasses that are germinating each fall. And Larry provided the example of the Ohlone tiger beetle, and that's one of the species that, for example, needs bare ground. So that's also something, not in large quantities, but many of our species need that, as well as some of our native plants. So this is the Santa Cruz tar plant. And I just wanted to point out this example where cattle were returned to Arana Gulch to help the endangered tar plant. And there was a lot of, I would think, community angst about returning cattle to this site, this coastal prairie. And in fact, a group of volunteers really tried to manage the thatch and vegetation in a different way. It's a 17-acre site. They were successful in 1 year in controlling or removing thatch from about a half an acre of it. And so it's not just that it was cut, but in order to remove the thatch, they had to, collect it and bag it up. And so it's just really hard to duplicate what cattle can do in this sort of effort. I have one final sort of point which often comes up is why not use native grazers? And one that comes to mind is the tule elk. And we do have a Tule Elk up on Coyote Ridge, where I'm sure that they also contribute to managing the vegetation. The easy, I guess, answer is we have, they're hard to control. And we're really talking about a more targeted approach, if you would, to maintaining vegetation. And they're difficult to control, and including you need really robust fences. So there might be places where they could work as an herbivore, and particularly as a grass eater, and perform just like our cattle are. But in most places, we wouldn't have them in a way that we would want to even perhaps control them in that way, in order to achieve the sort of vegetation management that we can from livestock grazing. And I have and the slides will be distributed, a list of references as associated with my presentation. So thank you.
Great, thank you, Sheila. You can go ahead and unshare your screen. We have some time for questions and discussion. Del, I know you had your hand up earlier, but we were trying just to keep the presentation moving along. If you had anything you wanted to say now, I think you're still actually enabled to speak from the last time you spoke. And then also we had a question in the chat from earlier, and then I'll allow Janet after we get to those two things to take any of the.
Still, do you want me to go?
Yeah, go ahead.
Couple of questions. One is there the cows will take out like the coyote bush? Is that correct?
Go ahead, Stu.
They'll eat the seedlings.
Okay, that's good. That's a good thing. Okay, gotcha.
Yeah.
And the fire takes out all the biomass, but what's the cost of the cattle grazing?
So with the cattle grazing, there is a higher upfront cost in terms of installing infrastructure, but on an annual basis, the cost is significantly lower than what we are using right now to hire contractors to do work on an acreage basis. We're definitely getting a lot more area grazed or managed in using the cattle than we are able to with contractors. But there definitely is the cost associated with putting in the fencing and the water infrastructure to support the cattle grazing.
Okay, and of course, the San Mateo Mountain Board is used to my crazy ideas, but I'll just run one by you. Would it be effective to decrease the speed of traffic? Would that help at all with the nitrogen, especially along Guadalupe Canyon roadway?
I think we've addressed that before.
Yeah, the quick answer is it would be such a small decrease because
not worth it. Okay.
We're embedded in this broader urban plume.
Gotcha. And lastly, I liked, as I've been writing Hannah, trying to get scrub, some kind of a community and local scrub takeout with volunteers, sponsored by you guys. So anyway, that's it.
Yeah, that's great. Thank you, Del. Yeah.
Thanks, Del. Looks like we have a few other people with their hands raised.
Yes, thank you. We have another person, Scott, followed by Ariel. Hold on just a second. Scott, can you hear us?
Yeah. So I wasn't sure if we were taking more general questions yet or if there are more speakers to go, but
there are two more speakers to go, but we'll take general questions and see if we can address them.
I actually can wait till the end if there's going to be question time till the end, because mine are more for overview questions.
Okay.
Okay. Yeah, there will be time at the end. Yeah, we'll get back to you at the end.
Okay. Next we have Ariel. Ariel, please unmute your mic and begin speaking.
All right, thank you, everyone. I guess on Scott's point, is it preferable if I also wait until the end, or what does the panel think?
I'd say if you have any comments or questions directly related to the three presentations we were just listening to, then we'd like to hear them now. If you have any broader questions about the program that you think would be better to address at the very end after the next two presentations, then you can go ahead and say that.
Great, then I'll wait till the end. Thank you very much.
Thanks, Ariel.
Okay, we have two more speakers. Next is Ted, followed by Michelle. Ted.
Yeah, just a couple of comments, actually. One, I know everybody's trying to put the best face on grazing here, and grazing certainly is a viable means for managing herbaceous vegetation and suppressing woody vegetation if it's palatable. But I think you have to keep things balanced and also not attribute everything to grazing. Some of these concepts of the nitrogen deposition don't really take into account that there's differences in soil depth and soil moisture availability as you go from the top of a ridge down to the base of a hill that can contribute a lot to the amount of herbaceous growth you get, especially grass growth. And from year to year, you show lots of great fence line pictures and everything's great on this side, everything's terrible on the other side. And that can happen repeatedly, or that can happen certain years and not in other years. We've done enough work in grazing management monitoring that we know that the effects of soil moisture and due to the rainy season and how much rain is put on and the timing of that rain can have as much, if not more, impact on the grass biomass than a grazing regime, depending on the intensity of the grazing regime. So I think, I know everybody's trying to put the big face on grazing here, but I think for to be intellectually honest and whatnot, you have to make sure that people understand that there are negative impacts too. And one of those impacts is you can't always control the intensity of grazing and make it happen where you want it to happen. Some areas will get overgrazed even though you're trying not to have that happen. And the last point I'll raise at this point, we'll discuss it more later, is that cattle are a very good vector of soil-borne diseases. And we have data from other sites where we know that cattle are moving around soil pathogens, introduced soil pathogens between water sources, between different areas. And so that has to be taken into account in this whole subject, because you really don't want to be spreading these plant pathogens into different areas than they may already be existing in those sites. So see, my time's about up. I'll just stop there.
Thank you. Next we have, just a second, Michelle. Michelle, please accept this invitation. Unmute your mic and begin speaking.
Hi, this is Michelle Salmon. I grew up here in Brisbane on San Bruno Mountain, and there were still cattle on the mountain when I was a child, all the way up to the mid-60s. And I've seen a tremendous change on the mountain in my lifetime. And I'm really excited about the prospect of bringing grazing back to certain areas of the mountain, because the scrub succession and it has just been devastating to the biodiversity. So I'm very excited about this. I got chased by a bull when I was a kid hiking on the mountain. So I think this is great. And the presentations really spoke to me in terms of what the mountain was like when I was growing up versus what it's like now. And also I'm excited about even the water sources and the biodiversity that created, because they used to have these round concrete cisterns that the cows drink out of, and they're still there. Some of them are still there. And there was a huge amount of biodiversity around that as well. So I'm excited, and I really appreciate the work that you're doing, and the presentations were really good. I know there's a lot of caveats, but I'm all for this. That's it.
Michelle.
Thank you. I don't see any more hands raised, Evan. You're muted.
All right. Yeah, so good. We have just two presentations left. Next is Felix, and he'll be giving kind of an understanding of the work that he and Larry have been helping us to do as far as biomass and productivity sampling in our areas of interest. So whenever you're ready, Felix, go ahead and share your screen and get started.
All right, hopefully everybody can see that.
See it.
Okay, great. So thanks everybody for having me. Yeah, my name is Felix Ratcliffe. I work with Larry for LD Ford Consultants in Rangeland Conservation Science. And I'll be talking about a study that we did, and we worked with Hannah and Evan on this in June to look at biomass, height, and forage production in the 2 pilot grazing areas on San Bruno Mountain. So let's see now. Okay, great. So herbaceous biomass is the amount of above ground plant material from herbaceous plants like grasses and wildflowers. We're not in this talk going to be discussing biomass produced by shrubs or trees or other woody vegetation. As has been discussed in some of the previous presentations, many grasslands in California accumulate high levels of thatch from annual grasses, and this biomass can impair habitat for native plants, including the butterfly host plants on San Bruno Mountain. This primarily happens through competition for resources or by limiting opportunities for germination and establishment of the native plants and the host plants. You can see this photo here. I now know from seeing other people's presentations that this particular fence line has been exhibited a few times during this presentation. So forgive me for doing it again. But this is a photo from Kirby Canyon showing an ungrazed grassland on the left where there's higher levels of herbaceous biomass and thatch, and a grazed grassland on the right side of the fence where there's much lower levels of herbaceous biomass and much higher levels of native wildflowers. There's also an emerging body of research that's linking high levels of herbaceous biomass with declines in habitat quality for different wildlife species, including some grassland birds, some lizards, salamanders, including the California tiger salamander, frogs, and some mammals. So in this study, we had really 3 main objectives. The first objective was to provide some information to inform the grazing strategy that'll be used in the 2 pilot areas. The second objective was to provide information to guide stocking rate estimates for the pilot grazing study, because we have to know about how many cattle we could get out there and about for how long. And then the third purpose was to provide information on biomass conditions so that the effectiveness of the grazing program can be later assessed. So we characterized 3 elements of herbaceous biomass in the 2 pilot areas. The first element was the height of the biomass. So vegetation height relates to habitat quality for many wildlife species. But however, the effects of height on the host plants, while it's thought that higher vegetation will generally negatively affect the host plants, the exact effect of that height on the host plants is unknown on San Bruno Mountain. We used a measure of height called obstruction height, and you can see in the left-hand photo on this slide, there's a black and white pole. So to get obstruction height, we put a black and white pole out there called a Robel pole, and basically we look at where the vegetation obstructs this pole to determine how high the obstruction height of vegetation was. The second criteria that we looked at was the total weight of biomass. So total biomass relates to host plant occurrence and their density. However, specific biomass targets that would be used for enhancing host plants are not really well understood. So we know that the host plants generally don't do well with high levels of thatch, but those exact, say, pounds per acre units that we want to target with our grazing program are not yet well documented. So one reason that we're out there measuring this is hopefully to establish some better relationships here and better understand the influence of grazing and of reducing thatch on the host plants. So, but biomass or total biomass is often also measured in the fall, and at that point, at that time of the year, we could call it residual dry matter or RDM. You all may be familiar with that term. And RDM relates to other natural resource goals like erosion and the next year's forage production or the next year's species composition. So there's a lot of reasons that we're particularly interested in total biomass out there. And to measure total biomass, we put a little hoop out on the ground, and you can see in the middle photo here, there's a picture of a hoop and some clippers. We put a hoop out on the ground, we clip it. This is a hoop of a known size. We clip all the vegetation in it, we bag it, we dry it, and we weigh it. And then we can convert that weight into a pounds per acre number for the total amount of biomass on our rangeland. So then the third criteria that we looked at was production, or forage production. And production is a measurement of how much herbaceous forage is produced every year. It's an indicator of how much biomass is produced annually, which is important when thinking about how much biomass we are then going to want to remove to benefit the host plants and the butterflies. But it's also an indicator of how much forage is available for livestock. So as such, it's a key thing to know when we're setting initial stocking rates for livestock out there. A lot of areas in California have published production information from the NRCS and USDA, and the major soil types within the 2 pilot grazing areas do not have this information. They don't have production estimates. And so collecting this information before the grazing pilot starts is pretty important for our planning process. And so just quickly, to measure production, what we did is we basically just took the component of our total biomass sample that was actually grass that grew this year. We can differentiate between grass and wildflowers and forbs that grew this year from thatch that was from past years. And we pulled out the recent component and weighed it to get an estimate of, well, how much vegetation is produced in 1 year. And I just want to say an important caveat about production is that production is highly variable between years, and it's also highly variable spatially, as several people have pointed out here. 2020 was a very unusual rain year by all accounts, and it had, many of you may remember, we had basically a very severe drought in January and February of this year. Yet that was followed by these sort of well-timed and well-spaced rain events in March, April, and May, which actually brought us up to having a pretty decent production year all in all when looking at other rangelands around the Bay Area. So the way that we actually laid out these sampling plots is we used a grid-based sampling approach to measure these biomass conditions. So this resulted in sampling points spread across the pilot grazing areas. And these sampling points represented different slopes, soils, and vegetation composition. In these 2 pictures on the left, there's a photo or an aerial photo of the southeast slope, and on the right, the northeast ridge. And the larger light blue dots are the locations where we sampled biomass, and then the smaller green dots basically just show the underlying grid that we are drawing samples from. There was a second reason that we used this grid, other than just to be able to get a well-spaced sample that we could resample in future years. But another reason that we use this grid is because, at least in the northeast ridge, this grid has already been sampled for butterfly host plants. And so we wanted to provide some biomass information that could be relevant to potential future host plant surveys, hopefully to aid in analysis there. So now we'll go into the results of the field study. And I just want to emphasize before we look at these, that these data represent the ungrazed conditions, right? Grazing has not happened on these pilot areas yet. So, so what we found, if you look at the graph on the left, is that average biomass was pretty high. This is total biomass in both pilot grazing areas. So in the northeast ridge, biomass ranged between 3,000 and 7,000 pounds per acre. And in the southeast ridge, biomass ranged between about 1,500 and 7,700 pounds per acre. On average, both of these 2 areas had around 5,000 pounds per acre and were more or less indistinguishable from each other in terms of total biomass. So that's a lot of biomass out there. It's representative of fairly high amounts of biomass occurring in ungrazed areas that have in fairly productive years. So it's not off the charts, but it is definitely much higher than you would think was optimum for these study targets. So then if we move to the middle and think about average forage production in the northeast ridge was about 3,400 pounds per acre, while average forage production in the southeast slope was about 3,100 pounds per acre. And these 2 numbers were not significantly different from one another. And again, this is representative of fairly productive areas in the Coast Range, and so it's about what we might expect for a pretty productive site, and it may reflect well the fact that there is, you know, this nitrogen deposition and everything happening there, that we are seeing such production. And again, I just want to emphasize these numbers could be pretty different in a different rain year. In fact, we would expect them to be. So the third graph over on the right is average height. And so average obstruction height in the southeast slope was much higher than that of the northeast ridge. And so this may seem a little surprising given that the biomass and production were so similar between these areas. And if anything, we're a little bit higher in the northeast ridge. But the main reason that we think this is happening is basically because in the southeast slope has a large area that was dominated by very tall wild oats, Avena. And these plants, while they can grow really tall, they often don't form a really dense lower thatch layer, and therefore they don't necessarily build up more biomass than some of the other species of grasses, which might be lower but are more thatch forming. Generally, biomass and production values followed a few rules of thumb in the two grazing areas that can help us understand some of the ecological drivers at these sites. The ridges, generally with thinner soils and potentially less moisture holding capacity, as Ted pointed out, had less production and less total biomass than some of the slopes and lower elevation flat areas, which had much higher production and much greater total biomass. So we might be seeing some interaction of factors here, both in terms of soil moisture availability, soil depth, and also, like Stu was saying, nitrogen deposition being much higher at some of these lower slopes. So what are the expected results of the pilot grazing study, right? First of all, I guess I should give the caveat that grazing effects are typically not uniform, right? So we would expect to see some variation, and probably more variation in biomass conditions than we're currently seeing out there when you add something like grazing on top of the existing biomass. But target biomass and target vegetation heights will be set in the planning process before the introduction of grazing. Those aren't set yet. So I can't say exactly to what level these fields will be grazed down to at this point. But we can speculate a little bit on what this might look like under different scenarios. There's going to be a need remember that there's going to be a need for some minimum amount of residual dry matter maintained at the end of the grazing season to protect soil and other natural resources. But it's conceivable that many of these areas are going to go from upwards of 5,000 or 6,000 pounds per acre, like we're seeing now, down to more like 3,000 pounds per acre. So if you look at these photos, the one on the left shows about 6,000 pounds per acre. The one in the middle, and these are photos just taken straight down, the photo in the middle is showing about 3,000 pounds per acre. And in some cases, we might even see pounds per acre go down to closer to 1,000 pounds per acre, 1,200 pounds per acre, and that's shown on this photo on the right. So these photos are just meant to sort of give you a visual guide to what these reductions might look like, going from a very thatchy, very thick grassy layer to something much lower, where again, a lot of these native species have a much better chance of competing. So then the next question is, how does the grazing affect these grassland plants, the host plants that we want in particular? Are the host plants going to bounce back to higher levels than before grazing in these pastures? And if so, what levels of biomass or height seem to enhance these host plants the most? What other factors need to be considered when we're doing a grazing program like this, such as topography, soils, and weather patterns? So by continuing to monitor rangeland biomass, along with these host plants and butterflies, we can hopefully start to answer these questions. And this information will help then refine the management targets in terms of how much total biomass and height to have out there, and then feedback into the planning process and the adaptive management process. So thanks. With that, I'll pass it back to Evan.
Thank you, Felix. So we just have one last presentation. That's Larry. He'll be talking a bit about grazing strategy. And sorry to back you into a corner, Larry, but I'm hoping to save at least 5-10 minutes at the very end for questions and discussions. So if you can shoot to end around 4:20, that'd be great. But take it away whenever you're ready.
Okay, great. Thank you. So I'm going to try to give a condensed version of this presentation. We wanted to give some of the details about how we got the pilot grazing study started, in particular about how that relates to some of the grazing management strategy. this is my summary of, this is my list of the specific topics. We had to pick out where the pilot study areas would be. We had to figure out whether it was going to work for, for the establishment of infrastructure. Then we needed to see if we could make room for the division within each of the study areas for special management areas and flexible use areas. And then how are we going to manage and monitor grazing? How would we do adaptive management based on that, on the monitoring results? So basically, the pilot study areas had to be close enough to the roads that we could easily get the cattle up to these areas. It's not always easy. It also needed to be relatively quick for the monitoring workers to be able to get up there and have a look at what's going on. We wanted at least 2 study areas. We ended up with 2. Whoops. Sorry. We wanted to make sure that the targeted species and habitat were present in each of these areas. They needed to be adequate size for sampling of grassland conditions and habitat qualities. And then adequate size for this internal division of, special management and flexible use areas. So all this was done by Hannah and Evan. They figured it out. It seems to have worked really well. So these are the 2 study areas that have already been shown twice using this exact same photo. You can see that within each of the study areas, there's a hypothetical division for the flexible use field that has not been determined yet. Infrastructure requirements, this is often neglected. You've got to not only have external or perimeter fencing, but you've got to have some internal fencing. The external fencing has got to meet and be maintained to meet California Livestock Fencing Code, which means basically that it's built such that there's a reasonable likelihood that the cattle will stay inside and not get out onto the road, which could lead to a really bad accident. There need to be gates that are secure, not only for staying closed when the cattle come through, but also in case there are trespassers or other people that are going to be opening or closing those gates. That's not easy. And then access for the livestock means that a truck carrying the livestock can get to somewhere nearby. The truck can turn around, it can enter and exit highways safely, and basically, bring in the cattle safely to and from, and also remove them from the study areas. Often the access roads need to have culvert maintenance. You all, I'm sure, are aware of those kinds of problems that can develop. And then watering facilities, which have to include a source of the water, which may well be from a municipal water company. But then it has to be piped. You have to make decisions about whether the piping is going to be above ground or below ground. You've got to put in some good kinds of troughs like this one. This one is made of concrete. It's very durable. One of the most important things in a lot of places is to have a kind of a trough that will resist bullets that are fired by people trying to have some fun shooting their guns. So a good thick concrete trough like this is good. It needs to have a good wildlife friendly escape ramp on it. And it needs to have some kind of a hardened apron around it because you can expect a lot of impact from the cattle coming to drink. So here's an example from another location. I earlier showed a picture of Glenwood Preserve in Scotts Valley, California. So this is how we've been managing cattle there to benefit not only a Ohlone tiger beetle, but also a pond and some wetlands up to the north there. So we've divided the property up in order to make this work, where a lot of the land is for flexible use, so the grazing can be there at any time. But in the special management areas, we defer or remove the cattle by opening up a gate and pushing them into the flexible use field when the conditions are optimized for whatever our special resources are. And I can tell you it works really well because I can do it remotely with the livestock operator, with texting or phone calls and sending a photo. You know, is it about right? You know, are conditions about right for this time of year for the beetle habitat? Yes or no? I did this once when traveling on vacation, and it was really handy. So how do you generally, you know, create a plan or guidance for the agency managers, the livestock operators, and the monitors to achieve, you know, the desired results? Well, the first one is to focus on outcomes rather than on the specific grazing, the grazing method. The most effective way, I mentioned this before, was to define your goals and then the related objectives, and from each objective have a measurable performance standard. I just want to note that California state law requires that a licensed certified rangeland manager be in the lead on any kind of planning or monitoring of California grasslands that fit a certain set of criteria. I mentioned before about adaptive management. I think what really works well is to closely interact with park managers and the livestock operator to get the monitor to produce a result quickly after the field work is done. This is often completely neglected, and it's a lot of times too, when agencies try to do this for themselves, they just can't prioritize spending that time. And so that means that the information isn't available to anybody to help make decisions about adaptation. And a quick summary, select study areas that will work for all the people that are involved and all the livestock. Install the required infrastructure before grazing begins, which is often not easy because it's so expensive. Designate special management areas and flexible use areas. As I've said several times, clearly define the management goals, objectives, and performance standards so that everybody knows what you're aiming for and you can adjust it if it's not working. And that's it.
Thank you, Larry.
Thank you.
So we have 10 minutes left. We already have a couple questions before we move on to raised hands in the chat. We have one, can someone speak to concerns about erosion from the cattle? I'll pose that to the panel. Anybody would like to speak on that?
This is Larry. I can speak about that. Erosion is a major concern, of course. There is a certain amount of background erosion that's going to be happening whether or not you've got grazing. But the RDM, residual dry matter standards, are based upon research over the last 40 or 50 years. And it demonstrates what level of RDM should be left on a California annual grassland in order to minimize erosion. We could go into more detail about that some other time.
Okay. This next question.
I'm sorry, can I add one thing to that?
Sure, go ahead.
So also in the planning process, you know, when we're figuring out where, say, a cattle trough should go, where roads should go, you know, I mean, I don't expect a lot of road infrastructure building, but other sources of erosion in grazed rangeland could be high impact areas like around a trough, or for example, roads that aren't graded properly and things like that. So there's best management practices and planning elements that can really help reduce erosion in key areas just by siting infrastructure, you know, in areas that are less prone to erosion and making sure that certain criteria are met, for example, with road grading and things like that.
Okay, this next one was posed towards Sheila. Can targeted goat grazing be used for control of shrubs? Can Sheila describe why goats, sheep, or horses are not as appropriate as cattle grazers? What are expected impacts of cattle on human uses of the mountain? So that last part I suppose Hannah or I can take, but if Sheila, you could address the goat and sheep.
So yeah, absolutely. Targeted goat grazing can be used to control shrubs. It may or may not be useful at this particular site, and particularly would have issues because the focus is really on controlling the annual grasses and the thatch. And so a grazer, which is cattle, are going to be preferring the grass over the forbs, and the forbs are plants that we are hoping to enhance. So whereas you might be able to manage goats and sheep to do that, and even horses generally graze closer than either of the species, using cattle seems to be like the most appropriate tool, because really the major interest is on controlling grass. And then cattle themselves may also provide some brush control, both with grazing or the seedlings, as well as trampling may also improve that. So that's, in this case, why cattle are preferred over other species.
I'd also like to note that, you know, like Sheila was mentioning with the goats or sheep, they're less selective overall. Like if we were to put the goats in the same parcel grazing, they would be more likely to eat the lupin and the viola, which the cattle would be less likely to graze. And then I can lead into the question on expected impacts on human uses of the mountain. The two areas that we're looking at for the grazing pilot do not overlap or intersect with any park trails. So unlike some other public lands, specifically thinking some of the East Bay parks that have trails that intersect through grazing areas, this would not be happening in the areas that are grazed at San Bruno Mountain. So there wouldn't be any direct recreational impacts for the current use of the mountain on that would result from the grazing activities.
And also, as far as logistically and safety wise, we're working closely with our ranger staff in the planning process to make sure that everything is implemented in a well-coordinated way, and keeping them looped in on all of that. And we're planning on having, similar to other land agencies in the Bay Area, having forms and methods of notification for any types of incidents that might occur, or any kind of damage or escaped cattle, you know, whatever could possibly happen, setting up systems so that we can address them quickly. And there's another question, a final question. Hannah, maybe you could address this. For those unfamiliar, why has grazing not occurred before now, since it was stopped in the 60s?
It hasn't occurred before now. I mean, there have been a few times in the past few decades in which the conversation around introducing grazing has been revisited. At San Bruno Mountain, there was a thorough assessment or study completed in 2002, which was really looking at what would need to happen to reintroduce cattle grazing. But I guess the follow through and the allocation of resources to really focus on completing those that work to reintroduce cattle really wasn't happening until this recent effort. Going back to 2018 when we looked to start this pilot program.
Yeah, and importantly too, our natural resources management team at San Mateo County Parks is still recently fledgling and growing. So we kind of now have the capacity to start playing with these tools that have been at our disposal since the HCP was initially administered. There was one other question in the chat, and then Janet, if you can take over with any hands that have been raised. Would people be excluded from the areas completely? Concern over the shell mound and being able to access certain areas.
No, we don't anticipate that there's going to be complete exclusion. I anticipate that there's we just, our preference would be to not have, our maintained trails and maintained accesses for recreation traversing these areas. I know the Shell Mound is an area of special interest, and that would be, well protected, and for folks wanting to, continue to visit that area would be able to.
Great. Okay, so we just have a few minutes left. Janet, are there any hands raised?
Yeah, we have 5.
Okay. Who is up first?
Suzanne, are you unmuted right now?
Looks like she's unmuted, but I'm not hearing anything. Perhaps we can move on to the next.
Ariel?
All right, thank you very much. My question would proceed maybe on a concern that someone else raised in the chat, but my question was about the Shell Mound, if there were plans to construct any fencing around that area on the southeast slope, and if there's any experience from other parcels around the Bay Area where there's been procedures to limit any impacts from grazing on such sites.
Yeah, for any sensitive resources, including the Shell Mound, there's an area with a wet meadow as well. We'd be looking to have exclusion fencing protective of these sensitive areas where we don't want to have grazing activities occurring.
Thank you.
Yeah.
I'll also say before we move on, I know we're getting down to the wire here. If anybody has to leave, we can probably stay put and answer everyone's questions, but if anyone does have to leave and you had any questions that you wanted addressed, you can feel free to email me. Everyone here should have my email. Okay, Laura.
Yeah, hello, thanks.
Hi, Laura, I think we might have lost you. I heard you there for a second.
Yeah, Laura, it looks like you're muted again.
Hello,
Hi,
my name
Laura.
is Laura Cunningham, and I'm the California Director of Western Watersheds Project, which is a conservation organization. And I had 2 quick questions. I know that there are native perennial bunch grasses of the coastal prairie on San Bruno Mountain, such as many fescues and prairie June grass, needle grasses. And these are actually the ice cream plants that I think cows will go to first. And so I would like to ask if there's any plans to measure that component of San Bruno Mountain, the actual relict native coastal prairies. And then quickly, my second question is, did the county parks department analyze a prescribed fire alternative? Because I don't really see any discussion of why that was not really taken as like perhaps another pilot section could be burned even with cooperation of local tribes. I know cultural burning is actually becoming much more important in California, working with native tribal cultural specialists. So I'm just interested in seeing why the prescribed fire option was pretty eliminated quickly. Thank you.
Yeah, thanks, Laura. I'm happy to address those. So regarding the interest in measuring and monitoring other just general species composition, including native perennial grasses, our intent with the monitoring program we do is to capture changes in overall native species diversity as well, not just looking at host plants. So that is one thing we're hoping to work to capture through our monitoring as well. And we've done, at this point in time, we've done a baseline biological resources assessment that does look at a pretty thorough species composition of both of these locations. And so we would be looking to use that baseline data as a comparison over time as, you know, to see whether there are changes in that type of, you know, perennial grass cover species, bunch grasses and things like that, in addition to our host plants or our nectar plants. In terms of the prescribed fire, we've had other hurdles at this location for utilizing prescribed fire because of the proximity to the airport. And that has been one hurdle that has we've yet to really figure out a way to overcome, but it is prescribed burning is something we're interested in looking into further. And there's been interest from other folks about having a similar technical advisory committee, specifically looking at using prescribed fire, but we just haven't gotten to that point yet.
Thank you, Hannah. Next we have Scott, followed by Ted, before we go back and check if Suzanne's microphone is working. Scott, please accept this request and begin speaking. Scott, can you hear us? Scott?
Sorry, have you been able to hear me? I've been unmuted.
Oh, we can hear you now.
Okay.
Thanks, Scott.
So I was saying that I was kind of hoping this was not going to be really this sort of introductory grazing sales pitch, but more the nuts and bolts of what the actual plan was going to be, because I think that's what I'm mostly interested in. And so I have three kind of big questions. And one is that your TAC committee seems almost more like a project proponent committee. And I'm wondering if you've thought about expanding your TAC committee to include some more voices that aren't a priori the grazing proponents or the butterfly proponents. My second question is, I think we'd all be really interested in the grazing infrastructure development plans and the stocking rates monitoring and the adaptive management plan. And I heard you mention the baseline data, and I'm wondering if that NOMAD study at least is available for people to look at. And then finally, in your introductory materials on the website, there's mention of the Kirby Canyon grazing program, and I think it was mentioned in the talks today. And I believe the stocking rate there was about 1 cow-calf pair per 10 acres. And so I think the southeast field would be about, if that was the stocking rate, about 10 cow-calf pairs. So I'm wondering how that is economically viable for the livestock owner, and what kind of stopgaps you have to sort of make sure that the balance between what benefits the livestock owner and the overall balanced ecological conservation goal would be.
So I'd like to talk briefly about the Kirby Canyon versus San Bruno Mountain. I think the stocking rate will be higher at San Bruno Mountain because it's a much more productive grassland. And especially early on in the process, to get that initial reduction in biomass, stocking rates are probably going to be a little on the high side, but that's all to be determined.
Yeah, and I would just like to say, so the productivity study that's been completed, as well as the baseline biological resources study that NOMAD completed, those will be published to the website for people to see. There are initial recommendations on what a potential stocking rate could be based on the current measurements that were done for productivity and biomass. So that is included in the report, and what is something that we'll reassess in the season prior to bringing cattle out as well, just to verify those are the appropriate rates for that point in time. And I want to just, in terms of some of the other information yet to come, I think that this is essentially one of the first public meetings we've really held to get the word out and discuss what the grazing program plans are. And so I think that's why the content was really much more focused on setting the stage and talking about what types of considerations are going into the program. The studies that have been completed to date will inform a lot of the next steps in terms of a plan for installing infrastructure and those exact specifications, the plans for the monitoring and management plan, what we know about the baseline biological resources will inform what we want to and where we want to place monitoring transects or plots and things like that. And so all of those items are in the works and are coming, and definitely items that will be shared and discussed further as they get further developed.
Great. Next we have Ted, followed by Suzanne. Ted, please accept this invitation and unmute your mic and begin speaking. Ted?
Okay. If I'm unmuted, I'm ready to go. I just wanted to throw out another couple of, am I audible?
Yes, we can hear you, Ted.
Yep.
Okay, great. So just a couple of concepts in terms of this being a science-driven type of a project. I'm concerned that there's enough baseline to really be able to disentangle the effects of environment in year-to-year climate from grazing effects. And typically what you have to have are multiple years of baseline so that you can set some sort of variation and then see whether with layering on cattle grazing, you can get outside of that variation and see how much of the effect there is. So I think that in terms of designing this, it's important to consider those long-term effects and those effects of climate particularly. And things like nitrogen are postulated for being in effect there. I mean, there should be soil nitrogen level monitoring. I don't know why that hasn't really been brought up on the radar. And then the other main area I have a concern of being a plant pathologist is biosecurity of the site in terms of, are you going to be bringing in invasive pathogens, particularly Phytophthora species, with your cattle or with your infrastructure construction types of things? You can also be bringing in invasive weeds. The cattle operators have to be very careful about what they're bringing in and with the cows and where the cows have been the last time before they get there. Usually there's some kind of holding period to try to eliminate weed seeds from these things before they go on the sites. But if they're contaminated with soil, you can bring in soil pathogens there. So I think the devil is in the details on these things, and I'm hoping that you're addressing all these other kinds of concerns as you're developing this plan.
I'd like to speak to the experimental design in that there are going to be internal no-graze plots, internal exclosures, so we'll be able to do a direct comparison with the grazed areas outside, and that's amenable to a before-after control impact design. In this case, there'll be some replication on it. So I think we're on pretty strong statistical grounds if we use internal exclosures. With regard to the nitrogen deposition, nitrogen's a really slippery subject and slippery compound, and you don't necessarily see an increase in soil nitrogen with a snapshot. What you'd have to do is to measure the kind of continual production of nitrate and ammonium in the soil. And just to go back to your earlier comment on the nitrogen is that, the lower slopes don't necessarily have thicker soils because you have these little ridge lines. And I've been on sites down there where you're on a rocky ridge line at the bottom of the mountain, and it's definitely very thin soils, and wild oats are over your head. Then you head up the mountain to the same topographic position and there's very little grass. So I see the effects of the nitrogen deposition really quite strongly on San Bruno Mountain, and it's consistent with what's been shown elsewhere across California.
And I would just, in addition to what Stu said about the baseline data, we have this year's, we will have another round of baseline data collected in the year prior to introducing the cattle as well. And like Stu mentioned, there's going to be an internal way of comparison grazed versus ungrazed through the duration of the pilot as well. And in terms of introduction of invasives, we have typically like pre-existing and well-enforced standards already for all projects and work activities that occur at San Bruno Mountain that require, cleaning vehicles, cleaning equipment, cleaning tools before entering the HCP area. That's something that we really are stringent about with preventing introduction of pathogens and weeds species to the park, and something that we're serious about enforcing.
Thank you, Hannah. Next, we have Suzanne Baker. Suzanne, please accept this request and begin speaking.
Hi, this is Jeff. Can you hear me?
Yes.
Oh, hi. Sorry about the confusion. I'm using my wife's Zoom account, so I've got the wrong name there. This is Jeff Miller. I'm a senior conservation advocate with the Center for Biological Diversity, and I've been working on public lands grazing issues in the Bay Area for more than 20 years. And yeah, it's pretty clear that the 3 listed butterflies and their host plants are going to benefit immensely from a well-managed grazing program that has clear management objectives and outcomes and with adequate monitoring and oversight. But I want to kind of sound a few notes of caution from my experiences where I've seen too much public lands grazed in the Bay Area that's not well managed. And, for example, East Bay Parklands, where we've complained about overgrazing, we've been assured it meets agency standards, but then when we go out and measure RDM, it's nowhere near those standards. Or the example at Point Reyes and National Parklands, where you've got chronic problems with lease violations, including stalking excess cattle and allowing fences to fall into disrepair so that cattle can trespass and access more forage, and those seem to be problems with little monitoring and no enforcement. So those issues seem like they're being considered in the pilot program and by your team, but management regimes do tend to erode over time and with changes in agency personnel. And by the way, I vote for never letting Larry Ford retire. He seems to be well on top of those issues. So. But once you put in the infrastructure and have a grazing tenant with a vested interest, it can change the calculus about grazing decisions. So I just want to make sure you're thinking about these things because it's probably not going to be all of you who are sitting here 20 years from now making decisions about grazing. And then one question I have, I saw some references in the 2015 HCP assessment and some other documents about grazing in Solano County that the Solano Land Trust did, and it mentioned monitoring that started in 2008. I've never seen any published results from that. Does anyone knows the published results? Can you post those or send those around? I'd be curious to see those.
Yeah, thanks, Jeff. I can look into that and see if that is something that can be shared and posted along with our other resources on our grazing site. If that's something that can be publicly posted. In terms of an approach that we're, with our grazing pilot program, I think the initial key is that this is a limited term duration pilot in order to really effectively measure and monitor all of these criteria and the success overall. And the lease and contract we get into with a grazing tenant is going to be built very specifically, and we're going to take a lot of consideration into the type of relationship that we will be able to build with a grazing tenant, because we agree that we don't want to have these issues where, you know, management or, you know, the targets that we're looking to maintain are not being met. You know, the overall goal is that this is a well-managed and well-implemented program.
Thank you. There are no more hands raised.
Okay, and so I think just to add on to what Evan said before, if anyone has any other questions or comments related to this, please email us and we can work to post answers and anything that we didn't properly address in our discussion or in the chat. We can also make a post to the website that addresses these questions and comments. And we hope to have future meetings that can get into more discussion about the next steps that we are working towards, you know, particularly when it comes to the more fleshed out monitoring and management plans. And just again, thank you all for your participation and for your attendance today.
Thanks to all the panelists and thanks to Janet for helping coordinate this.
All right, meeting adjourned.
Bye, everyone.